Hey guys, welcome to lesson 2. I'm going to start this one off. We are going to skip the warm-up and we are going to look at this question. When we are doing these Riemann sums or these rectangular sums, how can we make them more accurate? Okay, so we looked at the high, the low, and the middle, but how could we make it more accurate? And I have these amazing graphics as you can see, and on your paper I'm sure they're just as accurate. We talked about this last video actually, or 2 videos ago. The more intervals you add, the better it's going to be. So if I have just a quick sketch here, and I only do 2 rectangles, let's say I do a rectangle like that, and I do a rectangle a little bit lower, a rectangle like that. Okay, well that wouldn't be very accurate. Okay, on that same skirt, if I did a rectangle that was a little bit smaller, and a little bit smaller, and a little bit smaller, hey, all of a sudden it's looking a bit closer to the area of that curve, to the point where if I do really, really small rectangles, okay, it gets even more and more and more accurate. So the smaller my rectangles get, the skinnier my rectangles get, the more accurate it's going to be. And eventually, what we're going to do is we're going to look at what if I had an infinite amount of those rectangles. Okay, so that's all I wanted to talk about there. Okay, we're going to talk about this. We've got some equations that we'll talk about. The sum of regions could be defined as, holy Dinah. Okay, well that's what I talked about. Looking as our limit gets into infinity, what would the sum actually be? And this is the basis of an integral. Okay, so an integral is essentially the sum of all of those rectangles. This notation you don't really need to worry about. I'll talk about all the notation as we go. Here is the notation we should focus on. Okay. This is the integral. So this little s part, okay, is called the integral. And how I would read this is that I am taking the integral of c between a and b with respect to x. Or I'm taking the integral of c on the interval a to b with respect to x. And we'll see this a lot, and you'll be really, really used to this notation. An integral defines the area above an x-axis as positive area below the x-axis as negative area. And all I'm looking to do is find area between the x-axis and between the curve. So let's jump right into this first example. The graph of the function y equals f of x is shown below. It's only defined for 0 to 4, so just what it's shown, and has the following properties. It has symmetry about the point 2, 0. Okay, so that means that this and this are the same. This little blob and this little blob are the same, except they have odd symmetry. On the interval 0, 2, the graph is symmetric with respect to the line t equals 1. So that means like that line down there and that line down there, these are the same chunks. These ones would just be the reverse. And the integral of f of x between 0 and 1 is defined as 4/3. So the area under the curve between 0 and 1 is defined as 4/3. Okay, that is huge. Okay, that is huge. I'm just going to shuffle these over. Okay, we can actually go through, okay, and talk about this, and it's really, really cool. So since that is 4/3, and since I know this blurb is the same, oh, this would also be 4/3. Since this blurb is also the same, it would be 4/3, except it's below the x-axis, so it would be a negative area, and this one beside would be as well. So the area under this curve is actually 4/3. I know that with absolute certainty. Okay, we're going to do this example here. F of x is defined as the integral of f of x from 0 to x. We're talking about big f of x between 0 and x dx. Okay, well, I want to know what would the value be if that x was 0. So if I went from 0 to 0. So that's saying from here to here. Well, that would be 0. That's nothing. There is no area under that. It didn't travel any distance. There's no area. If x was 1, so now I'm going between 0 and 1, that area is what we've already defined. That would be 4/3. Okay. Between 0 and 2, all of a sudden I have 4/3. I have another 4/3. Altogether I have 8/3. For 3, now I'm going 4/3, and now I'm below the x-axis. And remember, we defined this as negative 4/3. So I would have 4/3 plus 4/3 minus 4/3. Oh, I just get 4/3. And if I went one step further and I went all the way to 4/3 plus 4/3 minus 4/3 minus 4/3, oh, I'm back to 0. So this area and this area cancel out. Okay, that's really cool. This area and this area cancel out. If I wanted to do my best estimate for the graph of f, okay, 0, my point is 0. 1, my point is 4/3. 4/3 would be like 1 1/3, somewhere about there. Okay, 8/3, well, that's like 2 1/3. About there. 4/3 again, and 0. Something like that. Hey, that looks like a familiar shape. Looks like a very familiar shape. Okay. Wonder if we're going to find out some interesting stuff about that later. Okay. We're going to do the same thing, okay, down below for question 2. Now this one is different. G at x, big G at x, is defined as the integral of f of x from 2 till x. So I'm always starting at this point here. That's really important. We always kind of started at the lower one and move this way like we would read a book, left to right. Here we're starting at 2, so I wonder how that's going to affect things. Same thing, all of these areas would be on their own, 4/3, 4/3, negative 4/3, negative 4/3. The integral is worth 4/3 or negative 4/3. If I set x as 0 and I go the integral of f of x between 2 and 0, 2 to 0, I'm going backwards. So I would have my 4/3, I would have another 4/3. Yes, that would be 8/3, but it's like directions. I'm going the wrong way. So that is actually defined as negative 8/3. When I'm going the other way, when it's defined the other way, I am going to go negative. That's really important. Okay, from 0 to 1, well, that would only be the half, that would only be 4/3, but again, I'm going the wrong way. Okay, my top number is actually smaller than my bottom number. That's really weird. Okay, from 2 to 2, well, I don't move anywhere, that's 0. From 2 to 3, oh, now I'm going places. Okay, now it just stays like normal. Normally, the area between this chunk and this chunk, it's negative 4/3. I'm moving in the proper direction, right to left, as I read a book. So everything stays the same. And I still get, I'll get 8/3 over here. I can go ahead and plot this. Negative. Ooh, it's a little bit hard to see on here. Point about here. Oh, no, I don't think I did that right. Can't see too well. 1, 2, and a bit. 1 and a bit. 0, 1 and a bit, 2 and a bit. Something like that, okay? If I was to plot it. That is what g of x is equal to, okay? I am going to stop this video and I will give you guys a chance to do question 2 here, okay? The answers for this are 0, 4/3, 8/3, and 4/3, okay, and then 0. And then you can draw the sketch. Okay, I'm not going to talk through that one. That's something you could do and just double check your answers. Okay, the next thing that you'll be working on is the homework assignment. You can grab that at the front. I would encourage you to draw a picture. Some information will be given, but it's really, really important that you draw a picture. That'll help you out a lot. Okay, and if you have any questions, the key will be at the front as well.